what you can see here, and we've got 4 at the moment, are combinations of these same 3 factors. Okay, x, x minus 2, and x plus 1. Okay, now with all 3 of these, no matter how you combine them, if you just multiply all of them, if you multiply a couple of them and divide, or multiply one and divide by the other 2, or switch them around, because they're the same factors, they will go through the same regions. Does that make sense? So what we're going to do is, because I've done a lot of the work for you, this is going to go quite quickly, but you'll see how it behaves across all of them. So stay with me. Now, perfect. Let's have a look at the first one. Okay. Now this guy is just a cubic. It's just a cubic. It'll be x cubed and some x squared and some x's and some constant. Right? So therefore, because I have to pass through here, I know that these 3 are all just intercepts. Does that make sense? And so you get a familiar cubic shape, something like that. And there's really nothing much else to it, right? I must pass through these regions, and I must pass through these intercepts, and that's all there is to it. And we've seen cubics like this before. This is not too super dramatic, okay? So that's a cubic. But where it starts to get really fun is where you start dividing by some of those things. Okay, so for instance here, have a look, right? Now it's already factorized. Let's do the next step, SFA for asymptotes, right? What asymptote do you see here?
0.
Okay, x is equal to 0, that's a vertical asymptote. Okay. Now later on I will show you how to find the fact that there's another asymptote here. It's oblique, and its equation, which we won't worry about at the moment, is x minus 1. So I've got a line going across like this. Okay, I'll show you how to determine that later. You don't have to be too concerned about that right now. But I've done my asymptotes. Y equals x minus 1. I've got an asymptote here, x equals 0. Okay, what was my other step? SFA I for intercepts. Where are the intercepts? Where do I get intercepts from?
X equals 0.
From the, I get them from the numerator, don't I? I get vertical asymptotes from the denominator, and I get intercepts from the numerator. They're 2 and negative 1. 2 and negative 1. I've already put my regions in here now. So where could a graph possibly go that goes through these regions, approaches these asymptotes, and intersects with those intercepts? Yeah.
Outside of the, so to
Yep.
the left of x equal to 0 and to the on top of the asymptote and reflected on the other side.
Okay, almost reflected, almost. You're getting something like this. Okay? That looks a little weird, doesn't it? But can you see, there's no other place the graph can go, right? Like, how else could it pass through this intercept and go through these regions and approach these asymptotes? Where else are you gonna wiggle around, right? Yeah,
So
Nikita.
does it mean it doesn't always have to go like towards the asymptote? Because in this one, it's like kind of stopping at the x. Will it ever cross the
Which asymptote are you talking about? The vertical or the oblique?
The oblique one?
Yes.
Will that line that you're on right now, will it ever cross the y-axis?
The y-axis. The y-axis?
Yeah.
No, it cannot, because, and this is something I'm alluding to, one of my later on examples will show this, okay? A vertical asymptote, because like I said, it has to do with domain, right? There is no way you can put x equals 0 into this. So this could never like break in over here and then come across the other side, right? For 2 reasons. Number 1, the vertical asymptote bars its way, right? Number 2, like this region is not shaded. I can't go there. The factors dictate that I have to stay on this side. If I want to be over here, it's going to be above the axis because of the region that I've shaded, that you guys shaded for me, okay? All right, let's move to this guy, okay? Again, same factors, right? Let's do the asymptotes first. Vertical ones are easier, so what can you see from the denominator?
0 and minus 1.
X equals, try to be more precise, okay? I know what you mean, but be precise. It's x equals 0 and x equals negative 1. So there's x equals negative 1, and here is x equals 0. Okay, that was a vertical asymptote. Do I have a horizontal or an oblique asymptote?
Horizontal.
How can we tell? The way that I work out whether it's horizontal or oblique is I compare the degrees of the top and the bottom. Degrees of the top and the bottom. Now, the degree here is 1, the degree here is 2. So a crude way of thinking about it is, this is going to grow, but this guy's going to grow so much faster, right? So when you take the quotient, you're going to approach 0. Is that okay? So I'm going to get a horizontal asymptote here of y equals 0. Can you see why it's more helpful to be precise and say x equals 0, y equals 0? They're different, completely different. Okay, now I need an intercept, don't I? Because it was SFAI for intercept. What intercepts would you like me to work out?
So there's not going to be any.
So there's not going to be more precise. There's not going to be a y-intercept, because if I put in x equals 0, I'm busted. So there's no y-intercept, right? But there is an x-intercept. Where do I get x-intercepts from? I get them from the numerator. X is going to be 2. Now hold on a second. Hold on. How do you define, what's the definition of an asymptote? Now, one way of defining an asymptote is to say, oh, it's a line you can't touch or you can't cross. But there's a problem with that. It's a little bit like saying, it's a little bit about saying prime numbers are like numbers that are factorized by one of themselves, but one is not prime, right? So it's like a close definition, but not quite. Okay, what's an asymptote really? An asymptote is some kind of line that you are approaching, right? Now, in normal circumstances, you would never actually touch the line because that's what approaching means. You're getting closer, but you never get there, okay? But tell me where horizontal and oblique asymptotes, I gave you a word, right, that told you where these guys are important. And I gave you some values that would tell you where they are. What was the word? It starts with E. Extremities, right? At the positive and negative ends, right? So therefore, horizontal and oblique asymptotes, what relevance do they have to the middle of the graph? Answer? None. They just tell you about what's happening over here. So now when you look at this guy, right? You're like, okay, I have this horizontal asymptote, but right there, he's blowing right through it. And he can. This horizontal asymptote, in fact, you'll see some people who, they graph, I need a piece of paper.
What's the point of it?
They graph like this. They kind of do their horizontal asymptotes here and here, because that's really where the horizontal asymptotes are important. Now, I don't recommend you do that because it just looks weird, okay? It's like the line keeps going, right? It's not like I just start and stop somewhere. I think this is a better way to do it, but it does capture the fact that this horizontal asymptote or this oblique asymptote, right? Like, look at here, for instance. This one we graphed before. See that? See that? Is the line, is the function approaching the oblique asymptote in here? Answer no, it's running away as fast as it possibly can. The oblique asymptote only takes over at the extremities. Does that make sense? Question.
Why is y equals 0 an asymptote?
Why is y equals 0 an asymptote? Because as I think about what happens when I put large values, positive or negative values, of into x, right? Into x, then I'm going to be approaching, for example, this will be like, say, 1,000 over 1,000,000, which is going to get closer to 0. It'll be 1,000,000 over 1,000,000, which will be approaching 0. Okay. All right. Yes. Last question.
Why is the second graph like the asymptote y equals 2x minus 1?
Hold on. This graph? You talking about that one?
Yeah.
I will talk about how to find the oblique asymptote afterwards. I'll tease the fact that, remember when we looked at this guy, right? The way that I knew that this was the oblique asymptote is because I saw the part that disappeared, and this is all that I have left, right? So how do you do that though? Like I presented it to you. I will show you, okay? But there are just so many ideas that you need to wrap around. Okay, so let's have a look at this guy. I think it's easiest to do the easy bits first, and then we'll leave the harder bits to later. Have a look on the left-hand side over here. I have to stay in this region. I have to obey these two asymptotes. So what's it gonna do? It's got nowhere else to go. Where else can it go? Right? It can't cross this vertical asymptote. It can't cross this horizontal one because the region tells it not to. You see how powerful this is, right? It locks in where you are. Have a look at this next one in here. Have a look in here. Right? Look, I've got two vertical asymptotes here. So I'm fenced in. And I've got a region that says you can't go anywhere in there, right? So this is what I've got. Where else can it go? Question.
Other way around, is that fine? Can we have it like upside down?
You mean like this?
Yeah, can we do that?
Well, can it be upside down? And the answer is it can't, because then it would have to stop somewhere, right? Now this graph, it has discontinuities, as you can see, but they're not discontinuities like that step graph we said before, where it's like, okay, I'm telling you, stop now, right? This just goes everywhere it possibly can, so it's going to get arrows, right? If it's got arrows and they're facing downwards like this, then the arrows are going to break through here and they're going to break out of my region, which I can't do. That's what the whole point of the regions is. Make sense? All right, hardest part now. We've got this to deal with, okay? Now, let's just think in terms of what you know. Think in terms of what you know. I have an intercept here, and I have negative to positive. Negative to positive. You agree with that?
Yeah.
So I'm going to have to come up through here, right? I'm going to have to come up. Now, obviously, if I think about now going towards the left, I'm approaching this vertical asymptote. So I'm going to be going downwards like that. Like I'd have to go further down to actually get closer. Like you'll see why I have to do this shape. Okay. So I'm going to get down like that to approach this asymptote. Don't move. But what's going to happen over here on the right? Well, okay. What's it going to do? It has to go up. Like this line, it can't just decide to like an absolute value. It can't just turn around like that. Okay. So it has to go up some distance. But we've already determined that at positive infinity, it's going to come toward this guy. So it has to turn around and then approach.
That's so weird.
That looks weird, right? But it can't do anything else. It must. It has no choice.